Hi, this is Josh from SpectraCal. Thank you for joining today's webinar on how to create a calibration 3D LUT in CalMAN Studio software. In this webinar, I will show you the step-by-step process for how easy it is to create a highly accurate 3D LUT for the color correction of your professional or broadcast monitor. There are three ways to apply a corrective 3D LUT. You can apply one in the editing software, the monitor itself, or in an inline 3D LUT box. Next week, on May 28th, we have a webinar and live Q&A session on creating and applying a corrective 3D LUT for DaVinci Resolve. In June, we have a webinar and live Q&A session for creating and applying a corrective 3D LUT directly into the monitor. And in July, we have a webinar and live Q&A session for creating and applying a corrective 3D LUT to an inline LUT box on a client viewing monitor that calibrates well, but needs a little more fine-tuning with a correction LUT. All of these webinars are completely free and accessible from your mobile device or desktop. If you'd like to attend any of these webinars, you can do so by clicking the link here, which will connect you with the registration page. If you have any questions during the presentation, feel free to post them in the chat box or on Twitter at the hashtag #VideoCalibration. The first thing I'm going to do is open up CalMAN Studio software. With CalMAN Studio open, I'll open up the workflow ColorCube 3D LUT. With that workflow selected, I'll click Start Session. This will open up the workflow that will go through the entire process of creating the corrective 3D LUT. With the workflow open, I'll click the Next button. Now that we're on the Hardware Connection tab, this is where you can select the meter that you're going to be using. And we've already got a video on this on our YouTube channel, so I won't review this. But if you need a refresher, you can go to our YouTube channel and watch the video on how to connect to a meter. The find source or signal pattern generator. Again, we have a video on that, so we're going to go ahead and skip this section. But if you want a refresher, you can go to the YouTube channel and watch it there. And here's where we connect to the 3D LUT cube generator. To start the process, I'll click Find 3D LUT Device, select SpectraCal as the manufacturer, Cube Generator 3D LUT under Model, and click Connect. Once we're connected to the Cube Generator engine, you'll notice that a green light came on the Hardware tab for the generator control, and we can also see all the options and settings for within the cube generator. Now that that's connected, I can go ahead and click the Next button. On the Session Options page, this is for configuring the input signal level. In this case, I'm going to leave it at the SMPTE range, but if I wanted to go to full range, I could do that here. The gamma standard, in this case, I'm going to use the ITU BT 1886 gamma formula, and the color gamut target or color space option. I've got currently D65 white point with HD Rec 709 color space standard selected. And for 95% of the use cases out there, this would be the standard used. But if for some reason you were working on a monitor that was had greater capability and you wanted to work within color space of like DCI P3, you could select the DCinema V1.2 or Adobe RGB, sRGB, or maybe you're doing some on-set work and you wanted to go to D32K at Rec 709, you could do that here. Or maybe even you're doing some research work on displays or projectors that are doing Rec 2020 or close to Rec 2020 Ultra HD standard. You could select that here. Since I've got what I wanted selected, I'm going to go ahead and click the Next button. And on this page, this is where we capture the color performance of the monitor's color characteristics before we apply a correction 3D LUT. Now this display has already been optimized, and I should note that it is a client type viewing monitor. It's not a broadcast monitor. This is just a consumer grade, a high-end consumer grade TV that's been somewhat optimized already. So I'm going to go ahead and open up my pattern source window. And I'm going to take a read series of the display's color performance before we create and apply a 3D LUT. For the convenience of this webinar, we're not measuring at the center of the screen, but we highly recommend whenever you're calibrating a display, you always keep the meter at the center. That's going to be the most color critical place of the monitor, And that's where the majority of the content is being shown anyways. So position the meter at the center of the screen when calibrating your display. And since it's going to take just a couple of seconds to read all these measurement points for grayscale and the color checker classic values, we'll go ahead and come back once it's complete. Okay, it looks like we're all complete with the measured values. I'm going to go ahead and click the next button. It looks like we didn't pass the delta E. We've got our white point is just a little bit over 3. We're going to go ahead and push forward with this, but the idea would be you want to get all these lights under the threshold so that you have 4 green lights, and then you go on to build your 3D LUT. In this case, it's close enough, so I'm just going to go ahead and move forward, but I just wanted to make a mention that these are just a quick test of how the display is performing beforehand. If we were going to go ahead and whittle away on this until we could fix that to make it a green light, I would click on the optimize display, which would walk me through a series of steps for calibrating the display further or optimizing the display's internal settings before creating the 3D LUT. In our last webinar, Optimizing Monitors Internal Controls for a 3D LUT, we go over this step in great detail. You can watch this webinar on our YouTube channel if you need additional assistance. Like I said, it's close enough, so I'm going to go ahead and click. This page is intended for devices or software that has a 1D LUT. Since we're creating a 3D LUT, I'm going to go ahead and skip this page and just click next. Now we're on the 3D LUT creation page. To start the 3D LUT creation process, I'm going to click the AutoCal dialog button down here, which looks like 2 spinning arrows. Once I've clicked that, you'll notice it brings up this AutoCal setup dialog. Here's where I can select the file format for the 3D LUT that I want to generate. Now, CalMAN supports all these formats. So whether you're creating a LUT for a software application, a monitor that supports direct loading of a 3D LUT, or you have an external 3D LUT box on a client monitor or a display that isn't performing well enough to the standard, then you can select the different file formats here. And as you can see, we support almost all the different formats, even the generic formats like .csv. So in this case, if you just wanted to spit out an Excel file, you could use another conversion tool to create that into any LUT format you want. In this example, I'm going to go ahead and use the .cube format. On the next section down, we have what's called pattern delay. I highly recommend doing the pattern delay optimization step every time you generate a 3D LUT. What this will do is it will synchronize the pattern changes with the meter capturing of the particular color patch change on the screen. Now, if there's any extra time that's being wasted, this will optimize and cut that time down so that it not only decreases the time it takes to make a 3D LUT, but it will also ensure that a read doesn't accidentally happen in between a pattern change when the monitor is refreshing between pattern changes. This will just ensure that you get the best quality 3D LUT that you can in the shortest amount of time possible. So I'm going to go ahead and click the Optimize button, and you'll see it will take a few different sets of pattern changes and readings. And it's going to take just a couple of seconds, so we'll let this run, and once it's done, we'll come back, and then we'll go through the 3D LUT cube settings. Okay, so now that the pattern delay optimization step is complete, let's go ahead and talk just a little bit about what's going on here. When it did the pattern optimization, we already talked about why it does it, but what it did is it set up the delay so that we don't waste any time between pattern changes and meter reads. So we're going to reduce the time it takes to create a 3D LUT. And then it also calculates how long an average read is. So that way, when it's generating the LUT for you, it can give you a good prediction of how long it's going to take to finish creating your 3D LUT. This is important for if you're doing a time-based 3D LUT, an IRP LUT, or a lightning LUT. Basically, any of the LUT formats that we're using, you want to make sure you've done this step so that way it can more accurately give you a prediction of how much longer it has to complete the particular 3D LUT output. Now that that's done, I'll go ahead and come down to the 3D LUT settings. These are the 3 types I just described. Time-based, if you've got 2 hours and you want to run it and do as much correction as you can this amount of time. IR profile, which is if you want to have it do a certain number of points, or maybe you want it to run as many points it possibly can, you can set it and have it run all night long. Or in our case, we're going to run the lightning LUT. So I'll select lightning LUT. The profile path, this is where it's going to dump the 3D LUT file. I'm going to go ahead and leave it to the default. But if you want to create a folder location, or maybe you've got somewhere on the network where you store these, you can go ahead and point this to that directory and then also give it a new name other than the generic one. I always recommend naming it the standard that you've used and then also the display that it's being used for, or the software or the device. So in this demonstration, I'm just going to leave it as a default, and I'm going to go ahead and click the OK button. This process is going to take just under 100 readings, and the whole thing will be about 5 minutes or under. While it's doing this, I'm going to go ahead and let it run, and we'll come back once it's complete. It looks like the Lightning LUT has finished its calibration of the 3D LUT in just under 5 minutes. I'm going to go ahead and click the next button to see how we did. Before I click the read series to see how this display is performing after the 3D LUT's been created, I'm going to go ahead and enable the virtual LUT. What the virtual LUT enables is it pipes in the correction LUT through the pattern generator source. That way we can see how well the display would be performing with the LUT applied. We're doing this because we're not actually loading the LUT into the monitor itself or a LUT box for this webinar. So I'm going to go ahead and enable the virtual LUT, and with that selected, go back down and do a read series and measure all the same color values we measured before we started the process. This is going to take just a few seconds, so while it's doing this, we'll let it run and we'll come back once it's complete. Okay, so it looks like it's finished measuring all the color values. I can see here that I've got a grayscale average error of just slightly over 1, a max of around 2, and the color checker average and max are both under 3. So again, this is not a broadcast or reference monitor. This is a client viewing type display, and we've only applied a Lightning LUT. And this is actually pretty good. I would say, you know, for this particular scenario, this is a good setup. I can go ahead and click save, which will save all the data that we've measured. So if we want to pull this back up at a later point in time, we can look at the pre and post calibration and maybe even compare it to future calibration sessions. And I'm going to go ahead and click save session and view report. That's going to load up and pull all the data together in one report that I can then output as a PDF file or for printing. So that way I can print it out and apply it to the back of the display. You can see all the different hardware that I used, the standards that I've selected, the pre and post calibration report showing the color space, color checker values, the RGB balance, the gamma, and then the color checker classic values. Now that that's complete, I'll click the red X in the top right. That will exit out of the reporting system and put me back into the workflow. And that concludes this webinar. We're going to go ahead and dive into the live Q&A session right now. So if you didn't type in any question in the chat box, please feel free to do so now, or you can go ahead and send a tweet to the hashtag video calibration. All right, so thank you guys for joining today's webinar. If you have any questions, please feel free just to post those to the hashtag on Twitter at video calibration, and we can get those in a live stream. Just as another reminder, we've got some great webinars coming up. We've got one next week that's going to be on creating software LUTs. Specifically in the example, we'll be using DaVinci Resolve. That's on May 28th at 10 a.m. Same format, same configuration. We'll have it streaming live on YouTube and Google+. We'll also have it on our Twitter feed, so you can sign up in any of those platforms that you prefer. And then also on June 18th, we've got one on calibrating and creating a corrective 3D LUT for a broadcast, a professional type monitor that supports the ability to load a 3D LUT. And then also loading a LUT into an inline LUT box on July 16th. So we hope you join us for those. Go ahead and feel free to post in your questions, and we'll take them as they come in. Thank you so much. Oh, looks like our first question is on, we've had this one before, but it's always a good one just to kind of go over this again. They're asking about a 1D LUT and the differences between that and a 3D LUT, and what are the benefits. So Tyler, you want to go ahead and dive into this one a little bit?
Yeah, so a 1D LUT just fixes the white point, grayscale, and gamma of the display. It does nothing for correcting the color space and the color gamut, whereas the 3D LUT adjusts the whole volume of the color space, including grayscale and gamma and white point.
Thank you, Tyler. That's a good explanation of the 1D and 3D LUT. One question we often get, and this wasn't specifically somebody posted on our feed, but we often get here at SpectraCal is, so I've calibrated my display with its built-in internal settings. How do I make it better than it is? I mean, let's say I found a trouble area and it's not good enough. And this kind of ties back into what we're talking about now with 3D LUTs. So I guess what I'm trying to get at is, how does a 3D LUT do more than what the internal settings can't do?
Well, the internal settings, most displays only have like a gamma preset, and they'll have like a 2-point white balance control. So they can only adjust the white balance at 2 points, and they can just adjust the gamma to one of its presets. Whereas if you do a 3D LUT, you can adjust it at much more points, and the normal size of a LUT in Hollywood and in other industries is a 17-point. People are making bigger ones, but a 17-point has almost 5,000 adjustment points in the whole color space, versus some displays will have like a color management system where it can adjust 6 points on the edge of the gamut versus 5,000 adjustment points in the whole volume of the color space. So you get a much more detailed calibration, and any nonlinear areas in the color space will be corrected that they might not show up when you're just adjusting the edge of the gamut.
Looks like we just got a question in here, and we did cover a little bit of this in the webinar, but they're just wondering, how long does a typical LUT take? Certainly a good question.
Well, our Lightning LUT feature takes less than 5 minutes, and that would apply to like broadcast LCDs and OLEDs. Our IRP profiling, that depends on how fast your meter is. Let's just say a 2,000 point IRP profile. A Klein K10 or something like the colorimetry research CR100 only takes about 30 minutes, whereas slower meters like the i1 Display Pro can take between 1 and 2 hours for that same amount of readings.
That's a good point to mention. So it's really dependent on how linear the display is, and also what equipment you're using. And of course, in the presentation, we talked about making sure you use the optimization, the pattern optimization. So we're cutting out any wasted time, and then also making sure that we're making a quality LUT by not accidentally taking readings in between pattern changes. So certainly that's a really good question. Here's another one that somebody just put in, and this is still, you probably read it in the news. There's a lot of conversation around this. So this person says, I keep hearing about HDR. Can you tell us anything you know about that? Or, like some of the things that may be coming up. And now we can't talk about all the details here, but we can certainly cover just maybe a couple of things. Tyler, do you want to?
Well, CalMAN Ultimate and CalMAN Studio, as of our latest beta, already support the ST2084 SMPTE spec, also known as Dolby PQ, and it's a new EOTF or gamma formula. It's not really gamma, but most people, when they refer to this, as a gamma formula. That's the new HDR spec for what the EOTF is, how it goes from black to white, the shape of that curve, and that's already supported in CalMAN. We also already support measuring the Rec 2020 color space, which isn't exactly related to HDR, but it is a new technology that is going to be coming up more and more.
And so with some of the new displays that are coming out, and some of the ones that we saw at a recent NAB show in Las Vegas, they're really putting out a ton of nit values, substantially more than the current displays. Traditional displays doing anywhere from 40 to maybe 80 or something like that. And now the displays are pushing 600, 1,000, and even beyond. How does that fold into the calibration equipment?
Well, one thing you have to be aware of is that your display isn't brighter than what your meter is capable of. A meter like the C6 or the I1 Display Pro, they can only read up to 1,000 nits. Something like the K10 or the CR100 can read over 5,000 nits, so they're pretty future-proof. So if you are going to be needing to measure HDR, you'd probably want to move up to a higher-end meter, because right now people are really targeting about 1,000 around this year for HDR TVs and post-production monitors and stuff like that, but that's going to keep ramping up every year. So if you are thinking about that HDR is going to be important for your measurement purposes, then you probably want to move up to a higher meter that's going to be future-proof.
Oh, that's a great explanation of that. So somebody asked what EOTF is, and we won't go into the great detail, but basically EOTF stands for Electro-Optical Transfer Function. There's a bunch of great information on the web at the ITU website, International Telecommunications Union. So great information there on that.
Yeah, and if you have any questions about HDR and CalMAN, you can contact us or contact support@spectracal.com, and we can answer any questions you have and how that would relate to your workflow with regards to calibration and measurement.
Thank you so much, Tyler. Well, it looks like we're just about running out of time here. We appreciate you joining this event. If for some reason you got in here halfway through, we're going to be putting this into a YouTube video shortly after and sending out a link. So if you didn't register, go to our website, one of the social media pages here, and sign up for this webinar or the previous webinar or some of the upcoming ones. And then we'll make sure we get you a link to this so you can watch it from the beginning. Thanks so much, and we'll see you next week.